So Jai Hind to all. This is Babita Rajput, Ajay Kumar Garg Engineering College, Ghaziabad. So today in the lecture series of computer network, we are taking the second lecture in this series. So let's get start today's presentation and today's lecture. So first of all, we are discussing access control. Before discuss this particular topic, we make we have some outcomes. Upon the completion of this lecture, learners definitely will learn about the multiple access control protocols. So we have a different kinds of protocols to complete the functionality of multiple access. Then we will understand the CSMA protocol specially, because we have some categories of the access control protocols, but among the all protocols we discuss the mainly CSMA protocols in this lecture, right? And after that we will talk about some kinds of CSMA protocols, and after that definitely we will discuss some we understand the functionality of three persistent methods. So basically these are some types of protocols which is implemented in the CSMA. So let's get start. But before discussing this particular topic, we take a recap of the previous lecture. So in the last lecture series, we discussed about the network and the communication. So network is the combination of some kind of autonomous devices. We can say autonomous networks. So we talked about the way of designing networks. We have some kind of configuration like OSI framework and TCP model. So this particular layered structure architecture provide the configuration of the network, and then we will talk about the some kind of autonomous network working process. Definitely if we have a device here and we have a device here, and how these devices communicate with each other by using network. So basically we perform some set of rules, and we are taking some configuration types, like we talked about some topologies and protocols also. So these some basic concepts related the first unit, and we already discussed about in the previous lectures, right? So let's get start. So today's we are discussing the access control. So basically before discussing this, the main concept of the data link layer, because access control you can say the media access control is derived from this particular layer. We can say this is the main responsibility of the data link layer, because we already discussed about the OSI model, in which we have a 7 layer, and these layers divided in such way. If I am talking about the very first layer, that is called the physical layer, and after that we will talk about the data link layer. So data link layer is the second layer of the OSI model, right? So we have some different kind of responsibilities that is performed by the data link layer. First one is the physical addressing, because data link layer is divided into the two parts, that is the media access control and logical link control. So media access control, this is the main topic today we are discussing this, and logic control is performing some kind of responsibilities, that is this one. So basically physical addressing and access control is performed by the media access control, and flow control and error control is performed by the logical link control, and this is the framing, and this is intermediate functionality between the MAC and the means LLC. So basically framing is performed by the both layer of the data link layer. So basically in this slides we are what we are going to discuss, we are going to discuss data link layer is data link layer have a two sub layers, that is the logical link control and media access control. So this is the main concept on which we are discussing ahead, right? So come to the main topic, that is the multiple access protocol. So multiple access protocol and media access control is discussing in such way because this is the functionality of a Mac, and this particular task is implementing by using some category of the protocols, in which we have a first category, that is the random access control protocol, and second one is the controlled access protocol, and third one is your channelization protocol. So what will discussing ahead in the lecture series, we have a main concept, that is the CSMA, right? So basically, first of all, we understand this particular concept. What is the meaning of the media access, right? So if I am talking about the main concept, main origination point, so what is the media access? Media is a way. So basically, suppose you have a device A and you have a device B, and these device wants to communicate with each other, then how can we both of communicate? By using some media of communication. So this is the media. So basically, what come understand, the way by which we can communicate with each other, that is known as a media. What happened if on this media multiple device, what happen if on this media multiple device wants to communicate with each other? So basically, what I am what I want to say here, I want to say here, we have a shared medium, we have a shared path which is shared by the multiple devices, because all wants to communicate with each other and all wants to transfer some data. So basically, they are using a single medium or single media to transmit information or data from one place to another place. So what happen if multiple devices attempts the media to transmit the data? So basically, if this particular media also transfer some data, and also this particular device also sends some data, so what happen is here, the condition arise of collision, right? And what is this collision? Collision is a condition that stuck the transmission process, because this particular data not reach their destination, and also the data of this device not reach at the destination. So this is the condition of collision, and they may cause the some losses, may cause the some delay. So this is the problem. That's why we are using the multiple access control protocols, because the work, we can say the main purpose of the protocols is to synchronize the devices, because if this device and this device may vary in the configuration, so protocol force all devices must synchronize with each other to communicate themselves, right? So what is the reason why we study this particular topic? Here we understand the condition, that's why we are discussing this particular topic, and how can we implement and how can we work with the multiple access control. So basically, we categorize this particular protocols on the basis of load, because this particular medium or this particular path is shared by all the possible devices which are combined here, which are connected in the network, right? So basically, this particular categorization is done on the basis of load. if I am saying multiple access protocol is divided on the basis of load. Load, we can say the total amount of data. Yeah, we can say payload, right? So if we have a small, we have a less type of data load, we can say less type of means load, below average. If on your network you have a very less amount of data to transfer on the medium, then we will always prefer with this protocols, right? If we have a average type of load, we can say average, we can say small, limited number of devices attempts the data medium, we can say the network medium to transmit the data from one location to another location. That means it is a work in the controlled way. That's why we are using the controlled access protocol. If we have a large amount of data to send, we can say on the shared medium we have a large number of devices, and these devices share this particular medium to send the data in a huge amount of data at the one time, then we will use the concept, we will use the protocols of channelization, because in which this particular techniques or protocols divide the total bandwidths of the network according the means FDMA, TDMA and CDMA. So basically these are other concepts which will include in the multiple access control, but basically we are discussing in today's lecture only the CSMA, right? So let's get start with this topic. So what is the CSMA? CSMA is stands for carrier sense multiple access, right? So what is the meaning of carrier here? What is the meaning of sense here? And what is the meaning of multiple? So one by one we will understand the each terminology with this particular topic. So what is the meaning of carrier? So here the carrier means is a medium. If I am saying carrier is nothing but it is a medium. So what is the medium? Medium is nothing but it is a interconnection between two devices, right? Medium is a, just if I am saying, just for example, if I communicate with you, so with the help of network, so through which we will communicate with each other, this is the medium, right? So carrier is a medium. Sense, that means before transferring data on the shared medium, we have to check out the medium is idle or not. This is the sense. Multiple access because as already discussed, a shared medium is shared by the multiple devices to communicate with each other. So that's why it is a multiple access. So what is the meaning of CSMA? Because carrier sense multiple access. If I am talking about this particular concept is introduced against the it's a previous topic, that is the if I am taking, yes, this is the kind of random access, because random access is not defined a particular time slot on in which this particular slot you have to access the shared medium. There is the possibility any user, any device can attempt the transmission at any time. This is the kind of random access, right? So in this series we have a first protocol, that is the Aloha, and Aloha is just a normal way of transmitting the data, right? Just for example, if I am saying when you came out your home, you are not looking right and left because you just come out from your home. So basically if you have a traffic, lot of traffic on the road, you don't care about it, you just come out, right? So this is the way of transmitting data, because whenever you want to transmit the data on the shared medium, you just not check out the medium is available for you or not. That's why it is a random access, right? So CSMA is basically introduced to overcome the problem of the Aloha, because when we are using this kind of approach to transmit the data, yeah, you suppose that on the shared medium 100 plus devices are connected and all devices sends the data at the same time. So what happen is there, the condition is occur on that time, that is the collision, because not your data reach at your destination and not the other device data reach at your destination. So basically this is the main problem, because in the case of Aloha you have a lots of chance to collide your data, right? So this is not the smooth way of transmission. That's why we will come on the carrier sense multiple access, because in this protocol you first check your medium. Yeah, you can say the medium is available for you or not. That's why we work on this particular. So basically the meaning of the carrier sense is a carrier sense protocol. The principle of carrier sense, yeah, CSMA, is a sense before transmission, yeah, we can say listen before talk. This is the main principle that work behind the CSMA. What is it meaning? Let's get to understand this particular concept. Just suppose you have a shared medium, this, right? This is the shared medium, and you have some devices that connect in this particular medium. And what happen if this particular device sends some data, and this data travel on this medium, and at the same time this particular device sends the medium, and that it receive some message, yeah, you can say it realize the medium already busy, that is never sends its data, because medium already occupied by other devices. So basically what happened, it wait for some time, and after the completion and after the reaching all bits of the previous device at their destination, then it will send the data, right? So this is the approach which is used by the carrier sense protocol. So to overcome the problem of Aloha, so what is the problem within the Aloha? This is the problem of collision. So carrier sense multiple access overcome the problem of the Aloha and minimize the problem of collision. Okay, and if the number of collisions decrease in the network, so there is the possibility to increase the chance of performance, because if a number of collisions is occur less time, so basically you are experience the smooth transmission of your data. That's why it increase the performance. I'm not saying the collision is totally removed by the carrier sense multiple access, but I must say it reduce some number of collisions ratio, right? Not clearly, not completely reduce the chance of collision, but it overcome as compared to Aloha, right? Next, carrier sense. So there is the two approach. First, carrier busy. Carrier means the medium. If your medium is busy, that means already some particular devices take place to transmit the data. If your carrier is idle, that means there is a no transmission. You can transmit your data at the shared medium, right? So this is the approach. Next, we will talk about some kinds of CSMA. So here we have a mainly 3 categories, but sometime we will also discuss this particular type. This is the O persistent. So basically we have a 3 category, that is the 1 persistent, P persistent and non persistent. So what it this, let's get discuss. So first of all, we will talk about the one persistent method. So in the one persistent method, this is a very simple and straightforward, because in this method your devices which are connecting your shared medium continuously check the transmission medium to transmit the data. In this method, each station finds the network is idle. That means it can send the data, it can send its frame immediately. That's why the probability of to transmit the data is 1. And on this basis, on the basis of the probability 1, that's why its name is named as the one persistent method, right? So basically what happened, this is the shared medium. Just to suppose you have a multiple device, and if these device sends the data on the shared medium, the rest of the devices continuously check the shared medium till they get chance to transmit the data. As soon as possible, the transmission free from you can say the previous data reach its destination, then rest of the devices can immediately send their data. This is the case of one persistent method, right? So this method has the highest chance of collision, because more stations may find the line idle or sends their frame immediately. Because क्योंकि इसमें क्या होता है कि just to suppose कि some devices are waiting for transmit the data, and as soon as possible the transmission medium become free, then all devices attempts to transmit the data on the medium. So what is the possibility? There is the possibility more than one process या one devices may attempts at the same time for transmission. So there is the case of collision. So that means we can say one persistent method may have the chance of highest collision ratio. So that's why we are moving on the next method of the carrier sense, right? So this is the P persistent method. As its name implies, P persistent, also known as the probability persistent method. In this method, before this discussing this method, we are moving on the non-persistent method. Yeah. So basically, in the case of non-persistent method, in this method, station has a frame to send on the medium, and if the line is ideal, then it sends immediately. In case the line is busy, so what happened, what the device has do at that time, the device may wait for some time, and after the some time, and this time is maybe a random time, or you can say some after slots you define the you attempts your transmission, right? So this is the basic functionality of the non-persistent method. It is just opposite the one persistent method. As you see here, just you have this particular shared medium, and you can say the your transmission way through which you are transmitting. So basically, when a device attempts first time, it seems to be busy. You can say the shared medium already occupied by another device. So what happened? The same device attempts after a particular random time. So this random time may be a 5 second, 10 second, at any varying interval you can decide. So this is the random time. So after sensing, after this particular random time, this particular device again sends your medium to transmit the data. If at that time transmission medium also busy at that time, then again this device wait for some random time. So this is the basic approach in a non-persistent method. So what happened here, the possibility of the collision, because not necessary you are waiting for 10 seconds, but not necessary the other device also wait for 10 seconds. May be possible those devices are waiting for 15 minutes or 20 seconds. So that's why there is the less chance of collision. Because if I am taking an example, just for example, you are working in a you can say you are taking the example of trains. If you get you lost the one chance of taking one train, then you are waiting for some time, and other person may take the chance of with another train. So this is the basic approach. So what happened in the non-persistent method? Non-persistent approach reduce the chance of collision because it unlikely that the two or more station will wait same amount of time and retry to send the simultaneously, right? So however, this method reduce the efficiency of the network because the medium remains idle when there may be a station with the frame to send. So what this particular line tells about, suppose you have the case in which no one device wants to send the data, or no one device sends the transmission medium. So at that time there is the no data for transmission on the shared medium. This particular situation affects your data efficiency, sorry, your medium efficiency, because on that time your transmission idle and there is a no data to travel on the network. So this particular situation affects your the network efficiency and unutilization of the network benefits. Now we will discuss about the p-persistent method. So the p-persistent method is used if channel has a slot. That means I am discussing the previous two methods in which we are continuously sense the network, your medium, and you are sense your medium some interval, you can say a random, after a random time. But in the p-persistent method, to overcome the previously both methods, how it will, in this method your transmission, firstly you are continuously, that means there is the work for one persistent also and non-persistent also. So firstly device continuously check the medium. If your medium is not idle, so it wait for a probability time, we can say, to perform the some steps. These are the steps within the probability. Q is a 1 minus p. This is the wait time for a station beginning of the next time slot, and check the line again. If the line is idle, then it go to step first, right? If line is busy, it acts as a throw a collision has occurred and use the back off procedure, right? So let's get understand this particular scenario. In this scenario, if your transmission medium is idle, then you can send the data. So with the p probability, if your transmission medium is already busy, that means device has considered as the collision has occurred and use a some back off procedure. So this is the concept of the p-persistent method. So that's all about the this particular concept. Although this is not covered in the within a single lecture series, we will also take another lecture on this topic, and this is important for all the students who are pursuing MCA and BCA and also preparing for competition exam, because CSMA is the most important topic from the computer network, because this particular topic may also ask in the UGC and GATE exams also. So this is the all about. Thank you so much.